Hi students, let us continue with the dining philosopher problem. So in the previous video I just explained about how I can solve the dining philosopher problem in the initial state by using the sum of first variables. So if you go just simply using the sum of first variable, if you want to solve the dining philosopher problem, you may get the deadlock condition may rises. Now let us see the solution for that dining philosopher problem. So I am taking the shared data because all are sharing the same food, so that is the shared data. So for that shared data I am taking some variables, like let us take the state 5, because the 5 philosophers are there. The state 5 of this are thinking. Those 5 philosophers are thinking, or may hungry, or may eating. Any of this in 3 states. Means any of these in conditions, the 5 philosophers may be thinking, hungry and eating. So first initialize to all thinking. Let us take all the philosophers are thinking. First they are all philosophers are thinking. And the self, I am taking the variable self 5. So this is the semaphore. Self 5 is a semaphore variable. This is initialized to 0. Initialize to all 0. Okay, and I'm taking another variable mutex. So this is a semaphore variable which is initialized to 1. So self I'm initialize all to 0. All philosophers self is starting, it should be 0, and the mutex value is initialized to 1. And I'm taking here the left fork, whatever chopstick I'm taking, that should be I plus 4 mod 5. So this is the left neighbor. I'm writing this is the left neighbor, and the right neighbor should be, right is equal to I plus 1 modulo 5. This is indicates the right neighbor. So these are the conditions I am taking that before proceeding with the algorithm or the program. So let me write the solution for this dining philosopher problem. I am taking the philosopher I. So this is the first philosopher I am taking here. Okay. So first I am writing the code. After that I'll explain that state. Let us take state I is hungry. I may be anything. Here it may be a 0 philosopher, 1 philosopher, whatever it may be. The state of the first philosopher is hungry. So whenever he is hungry, he has to wait for mutex, and he has to call the functions test I. Next signal mutex. If state of I, that is a philosopher 0, let's take this, philosopher 0 is not equal to eating. He is not eating. So then he has to make the wait self of I, that is starting it is 0. He has to perform eating and call the wait mutex. After that I have to put down the fork. You have to call the function put down of I, and just call the signal mutex. So this is complete the philosopher I, the main function. So let me write this test and put down also, the test function and the put down function, then you'll understand what exactly it is. So let me write that function also. Here I am writing void test first. This test function, void test of let me take int I. Okay, void test int I. Now if state left, so just taking the left of the philosopher, state left is not equal to eating. Suppose that philosopher is not eating, and state of I, that is a philosopher 0, is hungry. He is not even eating and he is hungry, and state of right, that is the right side of his dish, is not eating, then only he can perform operation eating. State of I, that is the state 0, is eating. After eating, he has to play signal. He had to increment the self to next self 1. This is void test. So whenever the first philosopher, now I will explain this up to here. The state of I, let's take the philosopher 0. Okay, state of 0 is hungry. Okay, so whenever he is hungry, he is calling the wait mutex. So wait mutex, whenever the mutex I initialize to 1, so it becomes 0. So whenever it is 0, it enter into the critical section. So whenever it enter into the critical section, the philosopher just calling this test I. So the test of 0, that is the philosopher 0. So state of left, the left of the philosopher P0. So here this is a P0, the P0, this is the left and the right. So the left of the P0, so this is the left of the P0 is not eating, and at the same time the P0 is hungry, and at the same time the right is also not eating. Then he can eat, the food. Whenever these 3 conditions are satisfied, then only he can eat the food. Okay, if any one of the condition is not satisfied, it doesn't go to this test 1, it fails and go to the next signal, next mutex. Okay, it increment the mutex value and checks for the next. So now it is going for the next. If state of I, that is the 0, is not eating. Okay, so P0 is not eating. Okay, wait self of I. So it has to wait self of I. Self of I means the self of 0, that is 0. He has eating. And wait mutex. After that, he has to put down of I. So what is the put down of I? Let me write that. The put down of I, void put down of int I. So whenever this operation is over, okay, or he is not eating that, he can go for the next philosopher and checking the condition. So whenever, until the condition is satisfied, whenever the condition is satisfied, I have to put down the chopsticks. State of I, that is a 0, is thinking. So whenever he is thinking, just call the wait self of I, that is a 0. So now I have to test left and right neighbors, whether they are free or means they are completed or not, the neighbors. Now I call the test left. Again I have to execute these statements, and then test right, check whether the left and right are completed or not. Whenever those are completed, then I can put down that, then I call the signal mutex, means I am incrementing the value. So next philosopher can continue with eating. So here may suppose he is eating, the other person may enter into wait and another person will eat, and this person may enter into wait and this person may enter into wait until he releases the logs. So like that, they are in checking the conditions. So whenever the person is hungry and whenever the person wants to eat, then only the person will take the fork and he will eat. Suppose the adjacent person is also hungry and eating, he has to wait some little time whenever he releases the log. Okay. So this is about the solution for the dining philosopher. Thank you.